Okay, so now I'm ready to load my data into Minitab. It's all the data I didn't want was deleted, and I separated the 90s and the 2010s into separate rows, separate columns, cleaned up the data. So I'm going to open this from my downloads folder, and is it just this text file? Did it save it as a text file? I think it maybe did save it as a text file. Okay, because that's the last thing I modified. So let's try opening it, and hopefully it looks the way it's supposed to look. So this text file, let's hit open. Okay, it's slow. All right, that looks the way it's supposed to look. It's separated into the 90s and 2010s. So we'll hit OK. And I think it's all in there all right. So actually, the hard work is done. Getting this thing set up. That was most of what we needed to do. So now we just need to run the various statistical analysis that I asked you to do. So the first is we want the mean standard deviation, 95% confidence interval, and histogram for the 90s data. So that is under stat, basic statistics, one sample T is going to make our confidence interval. And display descriptive statistics is going to give us the mean standard deviation and histogram, I think. Or maybe we can do it all with one sample T. Let's run the one sample T first because we need the confidence interval, and hopefully it'll just tell us all the other stuff too. I think maybe it does. So one or some more samples. We want that first snow column. We don't need a hypothesis test. Under options, 95% confidence interval. Under graphs, we want a histogram. We'll check that. And I think we're good to go. So as long as this produces our mean and standard deviation, then this is going to give us everything we want. Okay, oops, I didn't select it. So select that, hit select. So snow is over here, and double check this. Okay, 95%, so I'll hit okay, see what we get. All right, so here's our mean. It's 0.1091 is our mean snowfall in inches. Of course, there's a huge standard deviation because there's tons of zeros, almost entirely zeros, and then like occasionally there's a really big number. And then our confidence interval for the mean snowfall, 0.0786 up to 0.1397. And then here's our histogram, which is really ugly for snow because there's so many zeros, and then there's just like a handful of tiny numbers down here, like where there's like a bunch in the single digit inches, and then there's like occasionally there is a number that's way high here. So the reason this goes up is because there actually was a snowfall that was like 24 inches. Okay, so your histograms will look nicer because the temperature histogram isn't like all piled on one number, and the precipitation will look kind of like this, but not quite as extreme where there's so many zeros. The zero column will be a little bit lower, and there'll be some other numbers here. All right, let's do the same thing for our second set of data, one sample T. We'll get rid of this snow, and we'll replace it with the other snow column. See what we get there. So here our mean is 0.09, standard deviation 0.78. Pretty similar confidence interval. They're both kind of around 0.1 inches, and then the graph looks a lot like it did before. All right, so you can actually just like right-click, copy graph, and then paste this over into your Word document. That's what I actually want you to submit as your project, is a Word document. So your Word document should just tell me the mean and standard deviation and confidence interval, and then copy and paste this histogram for each of your 2 decades. And then the one last thing you need to do is to run a 2-sample t-test. I've set it up so that each sample has its own column. The first sample is in the snow column. The second sample is in the snow 1 column. We are running a hypothesis test with the null hypothesis that they're equal and the alternative hypothesis that they're not equal. And I'm going to leave this box unchecked, as I usually do, the assume equal variances box. And then we're not going to do any graphs for this. So let's hit OK, and run our hypothesis test. So this actually redid the mean and standard deviation for each of them, but didn't redo the confidence interval. It has a confidence interval for the difference. And here's the p-value we got. I got a p-value 0.42. That is 42%. It's much greater than 5%. So I do not have evidence of a difference. Now, as far as my test is concerned, it's perfectly reasonable that snowfall hasn't changed between the 90s and 2010s. So depending on what year you choose and what variable you choose, you might find a difference or you might not. Some of them are different. Some of them are like particularly hot or particularly cold years or particularly wet years, or decades rather. So some people are going to get small p-values and some people are going to get big p-values depending on which different years and variables you choose. So you also copy that into your Word document, the p-value, and compare it to 5%. Say if you have strong evidence of a difference or you do not have strong evidence of a difference. And that's it. Save it, email it to me before Tuesday, May 5th. And the hard work is basically just cleaning up that text file and getting it into Minitab. Once it's there, it's not too hard to run these tests. So that's it for today. Short day.